it's Miss Sayer here in the lab, and I want to check in with you about what's going on for the last 2 weeks of school. Right now is the perfect time to think about what kind of science makes you the most curious and what kind of career you might want to consider after high school. For these last couple weeks of school, I'm going to create some videos that highlight the big topics of science that we covered this year in biomedical class and show you some ways that you can explore these concepts at home. The first video in my Explore Biomedical mini-series is all about forensics. This year we learned about tons of different ways that forensic scientists collect and analyze evidence that they find at crime scenes. Today I'm going to show you one more method that they use that's called chromatography. The root of the word chromatography is chroma, which means color. Chromatography is the idea that many colors that we see as just one color with our naked eye are actually made up of multiple different kinds of pigments or pure colors, and that you can separate them with a process called chromatography. Chromatography can be used to detect the different pigments in lots of different kinds of substances, including blood, lipstick, makeup, dye, gasoline, the pigment in somebody's eyes, lots of different things. But the one I'm going to show you today is focused on the ink found in pens. This method can be useful when you're trying to detect something like a forged check. This is a sketchy check that I made up today. It says 200,000, but I think that maybe somebody used a different pen to add those extra zeros on there and change it from 200 to 200,000. One of the ways that a forensic analyst or detective could solve this is by using chromatography to see if two different kinds of inks or pens were used to make this check. Here I have 5 different kinds of black pens and markers. To us, they all look the exact same, just like black ink. But different pen manufacturers are going to use slightly different cocktails of pigments in order to achieve their black color. So if we separate out black ink, sometimes we can see that different pigments were used on different pieces of paper. I'm going to show you how I set up this experiment and also how you can replicate this one at home if you want to try it out. To start a chromatography experiment, the main thing that you need is the substance that you're trying to analyze, such as this ink in this pen here. You need a paper that you're going to put your substance on, like I drew a line here across the paper. The best kind of paper to use would be one that's really absorbent. So this is actually cut up white paper towels, and you could use something like coffee filters, but regular paper would work okay too, and they even sell fancy chromatography paper on Amazon if you really want to try that out. The next thing you're going to need is some kind of container to hold a liquid, and you're going to need a solvent. A solvent is something that can move through the paper and separate out the pigments in your substance, like this ink. I'm using rubbing alcohol as my solvent, which works really well, but you could also use plain water. The goal here is to have a little bit of your liquid solvent in this container and to have your chromatography paper just resting in that liquid, but making sure that the liquid is not touching the line where your substance or your ink is. So you're going to want to suspend your paper on the top of the beaker. So what I'm going to do next is tape the paper to this popsicle stick at the right level before I pour my solvent in there, because I don't want the entire thing to get flooded. Make sure that you keep track of which substance is on which piece of paper. I made a note at the top of each one. You could also put the correct pen by the right beaker so that you keep track of it. Once you've got your beaker set up, it's time to pour in a little bit of your solvent. Remember, I'm using rubbing alcohol for this, but you could also use just plain water. Pour in just enough that it touches the paper towel. There doesn't need to be tons. As soon as you've added your solvent, watch and see what happens. The liquid is going to get pulled up the paper and you'll quickly be able to see it reacting with the ink. To make sure that you've gotten clear results, you can let this sit for a while, even overnight. Just make sure that you keep refilling your solvent to make sure that it's touching the paper. You should be able to see some of the pigments separating, and that shows up on these photos here. The reason why these pigments separate is because some pigment molecules are smaller and some are larger. The smaller ones are going to be pulled farther along with the solvent up the paper. This is similar to what we see in a gel electrophoresis plate, where the smaller fragments are pulled farther along the plate than the larger ones. You might also notice that some of your inks don't separate into pigments as much as the other ones. These inks would probably react differently to different solvents. You can experiment with different solvents. You can try using water, rubbing alcohol, vinegar, even nail polish remover. I took a photo of our mystery check during the chromatography process. Even though this was early on and hadn't completely separated into different pigments yet, you can see clearly how the two different inks are reacting differently to the solvent. This is exactly the kind of evidence that forensic scientists are looking for when they use chromatography. It looks like this check was no good after all. Are you ready to try out some forensic science at home? You can complete the Forensics Challenge by clicking on the link in Google Classroom. By completing the biomedical challenges that I'm posting for the last couple weeks of school, you can keep bringing up your grade for the 21st century standards. If you'd like to reassess on any of the standards that we covered this semester, make sure that you scroll all the way to the bottom and fill out this part of the form.